Hello and welcome to our Rubber Assembly Lubricants webinar. My name is Michelle Christian and I coordinate the sales and marketing for International Products Corporation. We'll begin with a brief overview of our company. International Products Corporation manufactures specialty chemical products with emphasis on precision cleaners and temporary rubber assembly lubricants. We were recently awarded the 2012 North American Automotive Assembly Lubricant Product Leadership Award from Frost & Sullivan. All of our products are manufactured in the U.S. at our New Jersey headquarters and are available worldwide. In an effort to save time and to provide you with as much information as possible, please submit your questions during the webinar. On your screen, you'll find a field where you can type your question right online, and at the conclusion, we'll answer all of your questions. Now, I'd like to just go over today's agenda. The first thing that we'll go over is why use an assembly lubricant, what an effective rubber lubricant provides, how assembly lubricants work, industries and applications, what to consider in choosing a lubricant, commonly used rubber lubricants, formulated lubricants. We'll go through some comparison charts, lubricant efficiency charts, lubrication over time charts, lubrication versus drying time, some sample tests, and then we'll close and address your questions. Now I'd like to introduce you to Tom McGuckin. He's our VP of Research. Tom has been with the company for over 12 years, and he handles all the aspects of research and product development. So I will pass this on to you, Tom.
Thanks, Michelle. I, too, want to thank everyone for attending today's webinar. I hope that you find it informative and useful in all your different areas of expertise. Okay, so why would you want to use a rubber assembly lubricant in the first place? Well, rubber materials are inherently difficult to install, remove, or otherwise manipulate, even when they're wet. Rubber tends to grip, it resists movement, and it likes to stay in place if it's properly seated. These benefits are also its major drawbacks, particularly when installing rubber parts. For example, O-rings have a tendency to roll or tear when they're being seated. If you're trying to cut rubber to exact measurements, it's very difficult, and it's also difficult to cut a very smooth surface. Misaligned parts are routinely occur because you have to overcome high assembly friction, and that often leads to damaged parts. And then finally, if you're dealing with these type of problems regularly, you're going to have to deal with sore muscles because of repetitive stress injury. So that's why rubber assembly lubricants exist. And a rubber lubricant should have certain features. First and foremost, they should reduce installation force. Rubber has a very high surface tension, and you can see that when water is on rubber, you notice the water beads up. The rubber prevents the water from spreading out and wetting the entire surface. So an effective lubricant should reduce that surface tension. And when it does that, it effectively wets out the entire rubber surface and allows the parts to slide into place, providing a very tight fit. Now, if you choose the correct rubber assembly lubricant, you should be able to design your parts with tighter tolerances. A half-inch ID hose should assemble very easily on a half-inch OD valve. Other uses for the assembly lubricants is to increase the torque installation. For example, if you're tightening down a flange to a specified torque, you should do it without having concern about the underlying gasket wrinkling or splitting. And this lubrication should be temporary. After you're done the assembly, you shouldn't have to worry about parts becoming disassembled or the torque being reduced. All of this should lead to improved product performance and also increased production rates. Also, you don't have to worry about the possibility of injuries. You can avoid musculoskeletal problems, carpal tunnel problems if you're using the correct lubricant. You should also notice reduced rejects of your parts. And then finally, the product you're working with should be environmentally friendly and easy to dispose. You shouldn't have to pay to remove hazardous waste, which could lead to greater costs for your facility. So next I want to talk about how rubber assembly lubricants work. And it's really a straightforward process. These lubricants provide what's called hydrodynamic lubrication, or also called boundary lubrication. They provide a thin film between two surfaces. One or two are the rubber surfaces. And it actually creates a gap or a separation between these two surfaces. The lubricant should fill in these gaps and also any holes or crevices that each of the surfaces have. And this overcomes the high surface tension of the rubber. When this is done, the lubricant allows the surfaces to slide across each other. So here's a sample of industries that benefit from rubber assembly lubricants. This is just a sample, but some of the more popular ones are automotive and truck, food and beverage, and then pump manufacturers. Here are some examples of some of the parts used in these industries. And again, the more popular ones are hoses, O-rings, seals, and tires. Here's an example of some of the products that are manufactured with the rubber lubricants. It's a diverse set of products ranging from rubber floor mats to large cranes several stories high. Also, O-rings that are only several millimeters in diameter compared to tires that are 4 or 5 feet in diameter. Specifically, here's some examples in the automotive industry where rubber components are used, and the use of the rubber lubricants could certainly assist with the installation of these. Here's an example of typical truck assembly applications as well. Okay, when choosing a rubber assembly lubricant, there are some important factors that you need to take into consideration. First of all is compatibility. Will the lubricant affect, obviously, the elastomer that you're working with and any adjacent parts that are most likely metal or plastic? The dry time. Does the product need to dry quickly? Do you want it to dry in a longer time, say 1 hour, 2 hours, or even 5 or 6? And the residue. Is it okay if the residue is conductive? And finally, the chemical composition of the lubricant itself. By nature of these products, handling them is routine. Workers are routinely exposed to them because they're manipulating the parts. So they should be safe to handle, and data should be available that proves that they're safe to handle. Now, what's interesting about these lubricants is they're routinely considered an afterthought to an assembly process. The parts that were seen in the previous slide are all manufactured to exact specifications and tolerances. And then only when the assembly of these parts is being done, it's realized that a lubricant is needed to help get the assembly accomplished. So what happens a lot of times is the closest chemical is used to do the assembly. More often than not, some of these are soap and water, alcohol, kerosene, silicone sprays, petroleum-based products such as motor oil, transmission fluid, power steering fluid, even Vaseline is sometimes used. There's a choice out there that is better than all the rest, and it's ester-based biodegradable choices. And that's what I want to talk about next. So what's so special about these ester-based products? First of all, they're manufactured under controlled conditions. After they're made, their purity is verified, and their chemical properties can be tested. So you know you're getting consistent compositions and low impurities. When they're made with vegetable or plant-derived feedstocks, they have the added benefit of being green. Also, esters have the reputation of very favorable compatibility. Unlike some of the traditional lubricants, petroleum-based products have a tendency to swell certain rubbers and damage plastics. Soap and water can actually cause corrosion of adjacent metal parts, And what's unique about the esters is if they come in contact with adjacent metal parts, the esters actually align themselves on the metal in such a way that they act as barriers to prevent water and subsequent corrosion from affecting the metal. Soap and water also can re-lubricate if they come in contact with water after the assembly. Also silicone. Silicone is a great lubricant. It provides a sustained lubrication. However, if painting or coating is done downstream from the assembly, silicone will not allow that to happen successfully. So what's so special about these esters? Well, their molecular structure is conducive to lubrication. The ester molecule is a specific arrangement of carbon and oxygen bonds, and this arrangement allows these elements to rotate around each other quite easier than other functional groups. And this is the essence of the lubrication. So a little bit of this ester product gives you excellent performance. So the adage, a little goes a long way, is certainly applicable. Another benefit of esters is they don't fluoresce. Many people need to test their assembled products for leaks after the fact. And a lot of times, depending on the lubricant they use, that lubricant will fluoresce, giving a false positive leak test. Esters are the first part of the assembly lubricant, but the real magic comes into play when they are emulsified. An emulsion is a mixture of oil and water. So by adding emulsifiers to the ester, it partially dissolves the ester into water, and this creates an opaque, milky white appearance. And why is this done? Because of synergy. The emulsion has better lubrication properties than the esters by themselves. The emulsion significantly reduces the surface tension of the rubber, and it allows the esters to get into all the nooks and crannies of the rubber. And this actually allows a very thin layer of esters to coat the rubber to get that hydrodynamic lubrication. And this is one of the reasons why these products are considered temporary lubricants. Because once the water portion of the lubricant evaporates, the ester film that's left behind is so thin and so minor that it can absorb into the elastomer and the part is dry to the touch. Unlike the traditional lubricants that you need to use a significant amount of volume in order to obtain the same amount of hydrodynamic lubrication. Okay, to compare esters versus traditional rubber lubricants, here's a chart on the next page. Both type of products obviously provide lubricity and reduce friction. However, ester-based emulsions are truly temporary. Once they dry, they will not reactivate, and it will result in tight-fitting parts. They won't dry out the rubber, and like I mentioned earlier, the esters align themselves in such a way to prevent corrosion of the metal parts. The residue is non-conductive. Esters also are not flammable, and they have negligible VOCs. Any excess emulsion can be washed away easily. They enjoy very good compatibility with elastomers, most plastics, and they do not swell any rubber parts. And then also, the treated assembled product can be coated and painted downstream. Finally, they're environmentally friendly and non-hazardous. Okay, here are some test results that we want to share that compares this ester technology with the traditional lubricants. So if you look at the chart on the right, the percent reduction of friction, you'll notice the top bar is 71%, and that's the formulated water and ester emulsion. And for example, if you have to install a tire onto a rim and it requires 100 pounds to do that without any lubricant, if you use one of these formulated ester emulsions, it reduces the friction to 71%, so that instead of using 100 pounds of force, you only need 29 pounds of force. The petroleum-based products do offer comparable lubricity. It reduces that force to 39 pounds. The formulated surfactant-based lubricant, I'll talk a little bit more in detail with the next slide. Soap and water and solvents, they also provide some lubrication, but obviously pale in comparison to the esters. So back to the formulated surfactant-based lubricant. Why would something like that be used when the esters are clearly better? Well, if you look at this next chart, it explains why. If you look at the blue line going across the 100% friction value, that corresponds to water used as an assembly lubricant. So again, if we go back to the example of putting the tire on the rim, even if you wet the tire before you do the assembly, it still requires 100 pounds to accomplish that assembly. If you look at the green line down at the bottom of the chart, that corresponds to a line of ester-based products known as P80. That reduces the friction to only about 30 pounds. But if you follow that line all the way along the x-axis, you'll notice that it slowly increases and it returns to 100%. So in other words, after the water evaporates and the esters get absorbed and you try to remove the tire, it's going to require 100 pounds to remove that. Now if you look at the silicone spray and the 75 mineral oil, you also get pretty good lubrication. But as you follow those lines out, you see they don't completely dry, and their lubrication is not so temporary. And the reason is silicone has a tendency to be an excellent lubricant, and it tends to stay around for quite a long time. On the other hand, mineral oil, because you have to add a significant amount of volume to get that hydrodynamic lubrication, you're always going to have excess on your parts. Now the last line, the purple line, corresponds to a formulated surfactant-based lubricant. And this product is called P80 Grip It. And as you can see, it doesn't offer the same lubrication as the other products. It only reduces friction to about 60%. But notice what happens as it dries. It actually increases above and beyond the dry assembly force. So again, if we go back to the tire example, if you install the tire using P80 Grip It, you need 60 pounds of force. However, after it dries and you try to remove it, you're going to need anywhere between 110 to 115 pounds. So that Grip It does provide some lubrication, and it also provides a tacky residue to promote the parts to stay together. There's another way of looking at the data. P80 Grip It reduces friction by 40%, if you see that on the top left chart. And then if you look at the chart on the right, its dry time is only 20 minutes. Going back to the chart on the left, the bottom one, P80 Emulsion, clearly the best lubricant, 70% reduction. It has a dry time of 1 hour. Now everything in between are different variations of the ester technology. Depending on your application, you may choose one over the other. For example, Ready Lube has almost as good lubrication as the P80 Emulsion, but it has a much quicker dry time. The P80 products that are abbreviated IFC stands for Incidental Food Contact. They're used for FDA-regulated industries. And finally, the P80 Sticks corresponds to gels, which has benefits for certain assembly applications. So now that we talked about the benefits of the ester emulsions, I want to now mention some of the data that should be available to you so that you can make informed choices in choosing the product. There are many different tests available to evaluate the compatibility of the lubricants and anything that comes in contact with them. Metal compatibility, elastic compatibility, and plastic compatibility all have ASTM test methods. So there should be data available to give you a level of comfort to know that the product is going to work successfully in your application. Also, lubrication tests should be available. How well does the lubricant work in your specific application? And these tests are usually done with force gauges. And in certain situations, your parts can actually be used as the test. Finally, chemical compatibility. Many people want to know, well, how does any residue affect a chemical that will eventually come in contact with it? For example, antifreeze, power steering fluid, gasoline. Will the addition of a lubricant residue darken the product? Will it cause a precipitate? Will it lower the boiling point? These are some important factors that need to be considered. The next chart shows elastomer compatibility of several P80 products. And I'm going to go through these quickly. But again, keep in mind you can download the entire webinar so that you can look at these slides in greater detail. But essentially this chart shows the percent swell of different elastomers when immersed in different lubricants. The 4 different P80 products are listed on the left. Water as a control, and then finally mineral oil because it is routinely used. The next chart is presented in the same format. Instead of swell data, it's percent hardness using a durometer, and then percent mass. How much does the elastomer coupon absorb the lubricant? The same type of test can be run on customers' parts. If you look at the photos at the top, engine mounts. These engine mounts were soaked in tap water as a control, a formulated rubber assembly lubricant emulsion, and then mineral oil. And you can see the significant swelling that occurred with the mineral oil. Same type of analysis was done on natural rubber coupons. They were cut 1 inch by 1 inch, and again the same type of test was performed. Tap water, formulated rubber assembly lubricant, and mineral oil. Also, specific tests can be tailored to suit your needs. For example, one customer wanted to know the effect of lubricants with radiator fluid, with coolant. So a test was set up, and basically comparing any darkening that would occur with certain metals before and after exposure. So a digital imaging technique was used to notice any differences after certain exposure times and after different samples were prepared, water, the coolant by itself, and then different amounts of the lubricant residue in the coolant. So this particular chart shows aluminum. The next one shows copper. And finally, the next one shows tin. And finally, spectroscopic techniques can be used to further evaluate the effects of the lubricant with any particular product. The 2 smaller charts on the left uses UV visible technique to determine any darkening a lubricant has on a specific coolant. So the top chart shows that if 0.25% of a lubricant is diluted into a certain antifreeze, you will see a slight darkening. However, the chart on the bottom, the curves are perfect overlays, so there is no effect in the color change. The chart on the right is an FTIR scan, which can be used over time to see any changes that happen at a molecular level, if there's any reaction that occurs with the products when they're mixed together, the products being the coolant and any residue from the lubricant. Okay, I just want to briefly summarize what we discussed about ester emulsion technology before I hand it back to Michelle. In order to be a truly temporary lubricant, these products should not contain any silicones, and they should not contain any petroleum distillates from a performance standpoint and also a compatibility standpoint. The esters alone have excellent surface compatibility. There should be no metals in temporary assembly lubricants. They're not needed. And furthermore, they'll also provide a potential for conductivity once the parts are in place. You have to be assured that the lubricant does not harm adjacent surfaces. They have to be safe to use and dispose of. They must be ergonomically beneficial. And then if too much is applied, they can be easily removed with soap and water. And finally, they need to be versatile. You should have choices available, so you shouldn't have to redesign an assembly process to accommodate a lubricant. So you should have application choices. If you like to use a brush, a dip, or a spray can, it should be fine to work with. You should be able to manage the volume applied. Finally, you should be able to select the proper lubricant based on the type of application. For example, if you're doing installations overhead or out of reach, perhaps it's easier to use a gel instead of a liquid. And then also, if your elastomers or plastics are not that porous, then you should be able to choose a product that leaves essentially no residue versus one, if you over-apply it, will leave a residue. And finally, they should be easy to use. You should be able to open it up and use it instead of mixing several components together or diluting it with water beforehand. Okay, that sums up my part of the presentation. Before I hand it back to Michelle, I want to thank you for joining us. I hope you found this informative, and if you have any questions, please call or email us.
Thank you, Tom. There's a number of technologies available from International Products on formulated lubricants. They include liquid and thixotropic formulas. Now, thixotropic basically means that the material will thin itself out where it can be used in sprayer bottles, and then it returns to its original gel state once it hits the surface. Also, water-based products, solvent-free products, negligible VOCs, and biodegradable products. Many formulated lubricants offer a number of benefits, including superior performance, excellent compatibility, quality assurance, and consistency. And then working with the specialty manufacturers, we can give you technical know-how and experience, as well as on-site laboratory for product performance and compatibility testing. In closing, we just want to review why temporary assembly lubricants are ideal for rubber assembly. You have tight-fitting parts, fewer rejects, and quality control and testing to ensure ingredient consistency. They also need to be safe to use, non-toxic, easy to handle, and easy to dispose of, have excellent surface compatibility, result in fewer injuries, and have technical support and data. There's also a number of NSF-certified formulations for food contact applications. So before we address your questions, please note that we will be sending you copies of all the compatibility tests, as well as a transcript of the questions and answers and our contact information. So please feel free to reach out to us if you have any additional questions. All right. Well, thank you again. We'll start with the first question. What is the conductivity of the lubricant? Does it change over time?
Well, since P80 is made with tap water, yes, it does have an initial conductivity. And roughly it's around 500 microsiemens. But what happens is, as the product evaporates, the conductivity basically drops to zero. And there is a chart on our website that actually shows this.
Okay, then we have another question. How do you determine the percentage of friction? Using the coefficient of friction?
We use a variation of the coefficient of friction ASTM test method. We basically use a force gauge, and then depending on the parts, we will do an assembly without any lubricant, and we assign that basically 100%. And then we coat the rubber and then reassemble the parts, and after we get the reduced assembly force, from that value, we can determine the percent friction.
Okay. Now, I just want to remind you also, if you still have any questions, you can go ahead and enter them, and we'll go ahead and we'll answer them. The next question is, what percentage of P80 is ester?
It depends on the product itself, and basically the range of the ester content for all the P80 products, it ranges from, say, 10 to about 40%.
Okay. The next question is, how about compatibility with powder coating on metal? For example, epoxy polyester type.
We have a lot of different compatibility data on our website. We have metal, elastomer, and plastics. And if the specific polymer is not listed there, and I don't think an epoxy polyester material is, then certainly give us an email or a call, and we could certainly run that for you.
Okay, the next question, are P80 lubricants compatible with urethanes?
Yes, they are. That's one that is listed on our website, and again, you'll be able to see the data that was shown similar to what was shown in the presentation.
Okay. All right. Now, here's a specific for automotive assembly. Can I diffuse safely? Radiation, I'm assuming that's rad hose, radiation hose, blow-off potential.
If I understand correctly, there's no hazards with using the product. And is there a potential for radiator hose to blow off? Well, that's specifically why P80 Grip It was created. A lot of people were using P80 Emulsion for that specific application, and then they were pressure testing the hoses about 15 minutes after assembly, and that wasn't a sufficient amount of time for the water to evaporate and for the esters to be absorbed. So Grip It is used extensively for that type of application.
Okay, we have another question regarding compatibility. Are there any materials known to be incompatible with esters?
You need to watch out for some plastics. Specifically, we found problems with polyphenylene oxide. I believe the brand name is called Norel. A lot of polycarbonates do not like many different materials. And acrylic, depending on how stressed the assembled part is, that may be a problem as well. So again, if you're using any of these grades of materials, I would certainly test beforehand.
Okay, the next question is, my assembled product creates a totally enclosed air pocket, and if the water does not evaporate, will the lubricant still be temporary?
In this case, you may notice that you'll get a longer lubrication time, but there are some techniques that you can do to apply the absolute minimum volume to the part. For example, instead of dipping the part in P80, you could simply drag it across a sponge that's soaked with P80. Because remember, you only need to wet the surface. And if you can do this, then certainly the assembled part will then dry. Or if it's difficult to change the application procedure that you currently have now, then I'd recommend that you try P80 Ready Lube or Grip It. These are lower viscosity products, so regardless if you dip your parts in them, you will have a very minor volume on the part.
Okay, looks like we have one more question. Are the food-grade products safer to use than the regular ones?
No, they're not. We've tested all of the P80 products, we had an independent lab test all the products for toxicity and for skin and eye irritation, and they all came back favorable. So none of the products are toxic, none of them are skin irritants, and none of them are eye irritants.
All right, looks like we have answered all of the questions out there. Again, we want to thank you for tuning in. Just a reminder that this webinar will be archived, so you're more than welcome to log back in and review it as many times as needed, or pass it along to your colleagues and invite them to register. We will be sending you a transcript of all of the questions and answers, as well as compatibility information that we mentioned in the webinar. We thank you again. You have all of our contact information if you have any additional questions. If you need products for sampling, we'd be more than happy to help you. Thank you again, and have a wonderful day.